In this unit, we are going to talk about one of the applications of the determinants to calculate the range of a matrix. We are going to see what the range of a matrix is, how it is defined, and how it is calculated. To do this, we must remember how the determinants of matrices of any size, 2, 3, 4, etc. are calculated. So we will start by saying that the determinant of a square matrix is a number associated with the matrix that will help you to know if the matrix is inverse or not, depending on whether it is valid or not, the determinant. It will also help us to calculate inverse matrices by the method of the adjoints, and it will also help us to know if the matrix has a row or column that is a linear combination of the others. For any square matrix, which is for which we can calculate determinants, then we will note in this way, det A, or with this expression here so that it is more comfortable throughout the presentation. So given a matrix B of order n times m, that is, with n rows and m columns, we are going to call less than order R to the determinant of any square matrix that we can build by selecting R rows and R columns in the matrix B. Normally, R has to be less than the number of rows and less than the number of columns to be able to select. So, for example, given this matrix B, minus 4, 3, minus 2, 5, 9, 1, then I can build a number of order 1 by selecting a row and a column, for example, minus 4, first row, first column. It could also be minus 2, first row, third column, or 9, second row, second column. That is, all of them would be less than order 1, less than order 2. Then I can select, for example, first row and second row with first column and second column. And I have minus 4, 3, 5, 9. That would be a square matrix whose determinant would be less than order 2, or also first column and third column, and first row and second row, minus 4, minus 2, 5, 1. That determinant is worth 6 and is a less than order 2 in the matrix B. As you can see, we can build several less than order 1 and several less than order 2. What we can never build is a less than order 3, since we cannot build any determinant of size 3 times 3 with this matrix B. Well, that's what we call less than order R associated with a matrix given B. If we want to talk about the range of the matrix B, then the range is defined as the order of the largest of the non-null minors, the highest order that we can build, and that the smallest one is non-null, and it will be denoted with the rank of B or RG of B. For example, for the matrix B that we have worked before, the rank is 2 because we have been able to find a smaller than order 2 different from 0, and it is the highest that we can build, since we can't build smaller of order 3 as we said before. Therefore, the rank of the matrix B would be 2. Let's see another example. A larger matrix that has 3 rows and 4 columns. This matrix, A. What is its rank? First, we would see that it has 3 rows and 4 columns. Therefore, we can build minors of order 1, minors of order 2, minors of order 3, but not minors of order 4, 3 would be the highest possible. Well, to know the rank, let's see if there is any minus of order 3 that is different from 0, since it would be the highest possible. Well, we build all the minors, the determinants of order 3 that we can build. All the minors of order 3 of that matrix are these that you see here. Well, let's choose, for example, the 3 rows, and the first, the second, and the third column, and it would have this minor here. Or the first, the second, and the fourth column, which would have this minor here. Or the first, the third, and the fourth, and it would have this other. Or the second, the third, and the fourth, and it would have this other. These are all the minors of order 3 that we can build for this matrix, A. We calculate the values of these determinants, and if any of them is different from 0, then the rank of A is 3. If all are 0, then we have to go to the minors of order 2 to see what happens. Well, in this case, all those determinants, all the minors of order 3 are 0, so we already know that the rank of the matrix is not 3. We have to see what happens with the minors of order 2. How many can we build minors of order 2? Well, a lot, but it is enough to find one that is different from 0 to conclude that the rank of the matrix is 2. For example, I can build the one of the first and second row and the first and second column, 1, 3, 0, 1. This determinant, if we calculate it, is 1, which is different from 0. Then we have found a determinant of order 2, different from 0. Therefore, we can conclude that the rank of the matrix A is 2. Well, this is the way to calculate ranks for matrices of any size, to know which is the highest order of the determinants, non-nulls that we can build of the minors, non-nulls that we can build for that matrix. Therefore, we have seen how the rank of a matrix is defined and how we would calculate it.